can start as okay. Everyone, thank you for joining this this seminar. So a very warm welcome to the 11th issue already of the VascAgeNet Webinars series. My name is Gerben. I'm an associate professor of epidemiology at the Amsterdam University Hospital in Amsterdam, the Netherlands. As you may know, VascAgeNet is a network of researchers from Europe, the United States, and Australia, who are working together to refine and harmonize and also promote the use of vascular aging measures in order to improve clinical practice and reduce the burden of cardiovascular disease globally. Before we start, I would just like to run over a few housekeeping points. First, your microphone should be muted, and if not, please make sure it's muted now. Second, this webinar is being live streamed onto YouTube, and it will be recorded and shared on our website following the webinar. To ask a question at the end of the webinar, please type it in the Q&A box. And finally, we will not be able to assist with any technical difficulties throughout the webinar, and we apologize for that. So, housekeeping behind us, it's my great pleasure to host this webinar and introduce our speaker, Professor Anna Jeroncic. She's a statistical editor with the Cochrane Review Group and a professor of biostatistics and research methodology at the University of Split, Croatia. She's also a member of the Statistical Specialists Network of the European Network for Health Technology Assessment and serves as an expert in research methodology and statistics for scientific advice at the European Medicines Agency. Anna received a National Science Award in 2017 for significant scientific achievements in applying biostatistical and bioinformatics tools to clinical studies. A recent research publication, she is a senior author, was awarded by the Irish Health Service Executive in 2020 for its impact on health service provision. And from 2018 on, Anna is leading a national project aimed at using biomarkers of vascular aging in cardiovascular risk stratification. She's actively involved in EU COST, VascAgeNet Action as the vice leader of the working group number 4. And she's leader and vice leader of the, and here's an abbreviation that I don't know, CFPWV, applanation tonometry subgroups, respectively. And this may be more familiar to you. So it's my pleasure to hand over today to Professor Anna Jeroncic, and she will talk on systematic reviews, an introduction to systematic reviews and meta-analysis. Anna, thank you very much for joining us, and floor is yours.
Thank you, Gerben, for this great introduction. And hello, everybody. As you already heard, I will give you today a brief introduction to systematic reviews and meta-analysis, which are scientific papers which are based of evidence-based decision-making in clinical environment. But before we talk about evidence-based medicine, I would like to open this presentation with a question. And the question is, what is the evidence? So, if we take any scientific paper from the database, and here we have an example of a paper which was cited 335 times and which concluded that red wine antioxidant resveratrol protects isolated red hearts from ischemia injury. So can we take the results of this paper for granted? And most of my students would say yes. So this is the evidence. However, we already know that we have many problems with scientific literature. Many studies in scientific databases are not do not have internal validity. That means that there is no appropriate control in these studies and that we cannot interpret the results in a unique way. There is an alternative explanation for these results. There are also many studies with different biases which distort our conclusions from these studies. And there are also problems with generalizability. Like for this study, we cannot use it to explain what is going on in humans just like that. So I would say that evidence in biomedicine needs to have three different characteristics. So first is that studies on which we base our evidence should be systematically and timely collected for scientific database. The second characteristic is that we need to have appropriate assessment of risk bias in included studies. So we need to know whether in collected studies there is some mistake or problem with methodology which could result in distorted results. And we need to have something called evidence synthesis. So let us go into each of these characteristics separately. If I want to illustrate why is it so important to systematically collect all the studies, all the relevant studies from the scientific database, I would use this illustration with Christmas balls. So if I'm not collecting every relevant study systematically, if I do it non-systematically, I can end up with 4 studies, of which 3 are black. And I can conclude that the majority of studies are black, which is not the case. I can also non-systematically collect studies like this. So I would conclude that majority of studies are white, which is again not the case. So by collecting non-systematically, we are affecting the overall result, the overall conclusion, and we need to stop that. So, regarding the appropriate assessment of risk of bias in included studies, here I showed one illustration. So this is a study with hypertensive patients where blood pressure is measured with sphygmomanometer. So let's assume that we have 2 measurers, one young and one older measurer in different groups. Because young measurer has better quality of hearing, he will record blood pressures at higher level than the older person with hearing problems. So just because we have different measurers, we can end up with intervention group having higher blood pressure than the control group, just because of the bias. We could also have another type of bias due to attrition of participants. So let us look here. We have 2 arms, 100 participants in each. One arm is receiving old drug and the second arm is receiving new drug. So we are interested in number of patients that are cured at the end. And we calculate this percentage, and it seems as the group with new drug cases is actually better than the old. However, what we didn't take into account is that 26 participants stopped using new drug and started treatment with old drug. So by concentrating only on number of patients at the end, we're actually introducing bias. We are changing conclusions from this study. Today we know that there are many, many different sources of bias. The Cochrane methodology group worked a lot on them and categorized them in several domains. So one is selection, and that means that we can select participants in our study which are not representative of population that we want to explore. We could have performance bias, like unconscious bias that exists with researcher and patients because they know in which arm they are assigned. We can have detection or attrition bias, which I already explained, or reporting bias. The researchers started with analyzing many different outcomes, and they can select the most interesting ones, so the outcomes with significant results. So that is reporting bias. Or we can have some other bias. For instance, we can have randomized controlled trial with a big difference between the groups at the beginning of the trial, which is again a problem. And the first characteristic which the best available evidence need to have is evidence synthesis. So we usually do it with meta-analysis, which is method that we use to summarize results from several different studies. So in this case, we have 5 studies that investigated change in blood pressure after giving antihypertensive drug to patients. In 2 studies, researchers found no significant results. In 3 studies, they found significant results, and they found the drug to be effective. So to improve our estimate of the efficacy of the drug, we will do meta-analysis, and we have combined estimate, which will tell us that we expect from this drug that typical patient will have reduction in blood pressure from -10 to -50. Majority of systematic reviews today also estimate overall quality of evidence using grade system. So while meta-analysis can tell us something about magnitude of it, which can be small, moderate, large, or something like that, there are different factors that we also need to take into account to judge whether evidence is weak, moderate, or strong. So let us look at this column. These are all different active ingredients of mouthwash. So in this column, we see that systematic review included 3 studies. Magnitude of the effect was large, but they also investigated reporting and methodological risk of bias, which was low to substantial. So we have 1 study with low risk of bias. They investigated consistency, heterogeneity of studies, so how studies are different, directness, where the outcome is really either directly assessing what we want to estimate, precision, publication bias, and so on. So for the 3rd column, we can conclude that the evidence is strong. Also, please note that in the 1st column, we have 1 study. Body of evidence is assessed as model. So here we have 1 study, which is evidence. However, it is evidence after we systematically collected all the studies and we assessed risk of bias. Another point, why I'm talking about the best available evidence. Sometimes for some research questions, we don't have enough studies, or we have poorly designed studies and we have weak evidence. So the best available evidence for your research question could be weak. So why do we talk about systematic reviews when we talk about evidence-based medicine evidence? I think the answer is in the very definition of systematic reviews. So if we look at the definition, it says a systematic review is the review where there is comprehensive search of relevant studies on specific topic, where those studies are appraised for risk of bias and synthesized according to predetermined and explicit methods. So the very definition of systematic review it actually includes 3 characteristics of an evidence that evidence needs to have. So it's no wonder that when we look at hierarchy of evidence, systematic reviews, if hopefully done correctly, are at the top of the spiral, and individual studies are below. If we are interested in studies investigating different interventions, then randomized controlled trials are the next best thing. However, if we are investigating diagnostic studies, then randomized controlled trials are not that good source of evidence. So this hierarchy of evidence could be slightly changed depending on what is your research question and what we are trying to answer. Another concept that needs to be clarified is that we often hear about papers with meta-analysis. Meta-analysis is just a statistical tool that we can use to summarize results from different studies. However, if meta-analysis is done without systematic collection of studies, then it is not the source of paper which we can use in evidence medicine. Also, we can also find systematic reviews without meta-analysis. It is quite okay to have a systematic review without meta-analysis if studies are so heterogeneous that you cannot summarize the results together. And of course, what we are actually hoping to find is systematic reviews with meta-analysis. So, if we want a cookbook how to do systematic reviews, here is one. We start with definition of the question, which is not that straightforward. You will see in a few slides. After that, we plan eligibility criteria for included studies and we plan methods. At this level, we should publish a protocol. After that, we search for the studies in the scientific databases. We apply eligibility criteria, collect data, assess studies for risk, analyze and present results, and interpret results and draw conclusions. And at this level, we publish a review. However, in evidence-based medicine, researchers do have a responsibility that if they've done one systematic review, after some time, it is expected that they improve and update review, because number of studies in medicine is growing at such a rate that it could be that conclusions of particular systematic review can be changed in a few years. So we need to update it. So regarding formulating a review question, it is important to formulate them well, because this formulation will guide many aspects of the review process, such as searching strategy, inclusion-exclusion criteria, data extraction, and choice of synthesis method, and presentation and dissemination of findings. How come? So here is one tool that we can use to define research question. It is called Pikachu tool, and we use it whenever we need to summarize facts from randomized controlled studies investigating different treatments. So we usually define population or participants that we are interested in, intervention, comparator, whether placebo or active treatment, and outcome. And based on these elements, we can combine these elements as a keyword. So we can use our definition of population with definition of intervention and search databases. Sometimes, if we combine all the elements, we can end up with a search with very small number of studies, and that is why we need to relax search a bit and not use all the elements. Sometimes we have maybe research question which is related to public health intervention. In that case, we use some other tool like SPICE, where some other elements are defined. So based on your research question, you need to find optimal tool for formulating research question for you. After we formulated research question, we defined a lot of things that we need to define, including eligibility criteria. After that, we start to develop protocol, and protocol is actually an essential component of systematic review process. In many high-impact journals, a protocol registration number is required. So why do we need to do a protocol? One reason is to reduce impact of bias. What does that mean? That means that we need to predefine the outcomes that we are going to use. If we start with a high number of outcomes, we may choose the best one to present in systematic review, and by doing that, we are actually biased. We can also have several different methods of synthesis, several different models of meta-analysis, and we can choose the best result. So to protect ourselves from that, we predefine both meta-analysis method and also other aspects of our systematic review development. We also need protocol to reduce duplication. If somebody else is developing a systematic review, we need to bypass that. We need to allow preview, and we also plan test and allocate resources with protocol so that we know that we have enough people on the board. So what do we pre-specify in the protocol? First, what studies will be included or excluded? Should we focus only on randomized controlled trial? Should we include cluster randomized trial, crossover trials? If we include them, how we are going to integrate them with other studies and so on. We need to define search strategy. We need to define tool with which we will critically appraise studies, synthesis methods with which we will investigate something called heterogeneity or differences between the studies and other things. And we need to predefine what are the primary and secondary outcomes of interest, because as I already explained, we can introduce bias by choosing afterwards which primary and secondary outcomes we like best. So in Cochrane system, here in blue, you see sections that need to be filled in order to submit protocol. So again, we need to explain background, why it's important to do systematic reviewing on this problem, objectives. So are we going to focus on which primary outcomes and secondary outcomes we are going to focus, which methods we are going to use, and some other sections. So one register that accepts systematic reviews is Prospero. We can search for ongoing reviews there, and we can register planned review online before we started the search. Because of COVID, currently Prospero is really busy, but hopefully that will change in the near future. And now about searching for studies. So I already explained why comprehensive search is so important, but I would also like to stress why it is not enough only to focus on popular studies. So if we think about the studies which are cited more than 1,000 times, we would all say, okay, these are high quality studies, so we believe in their results. However, in the work by John Ioannidis in JAMA 2005, John compared 45 popular studies with other studies with populations and methodologies that were similar or superior to these popular studies. And results have shown that when we compare these results, opposite, null findings, or much more dramatic differences between the studies were found in 31% of time. 83% non-randomized popular studies and 23% randomized controlled popular studies were subsequently contraindicated. So obviously, just by focusing on popular studies, we will not get the realistic estimate of effect. So how do we search? We need to select several databases, optimal 3. And the choice of databases will depend on the research question. However, most commonly we select Medline, Cochrane Central, and Bay. If we are interested in attitudes, we can search Psychlet, or we can include Sinachel or nursing data. Once we select the database, we need to get to know the rules, syntax of search in each database. So here we have a syntax for searching Medline database over PubMed. So there are several aspects of this database that are particularly important. First is mesh terms. So think of mesh terms as bookmarks that are put on records of different studies by specialists who read abstracts and categorized studies. So in a way, if I want to find all the studies talking about acute kidney problems, I will search for bookmark in mesh term. Downside of a mesh term is that newest studies are not included because it takes time to read all the studies bookmark. Another really good characteristic of this database is we can search for specific fields. So we can focus on just title and abstract, authors, or many different fields, which will help us focus our search. We can also use filters for different ages of patients, different journals, different study types, and so on and so forth. And we can combine them with Boolean operators. So other databases do have similar concepts. So in many different other databases, you also can use Boolean operators, which can allow you to combine to find the studies which have both keywords separated by and, or find studies which have either first or the second keywords, or find a study which contains first word but not the second word. Another really useful feature in Medline is nesting of keywords. So usually the command or search filter is interpreted from the left to the right. So in this example here, where we combined command called N in the brackets with vitamin Z or zinc, if we don't use brackets, the interpretation of database would be following. So command called and vitamin C. So we would have papers with common cold and vitamin C or zinc. So without brackets, I would also have papers on DNA binding proteins containing zinc in this search, and this is not related in any way with common cold and vitamin C. So by using brackets, we can identify different concepts and then combine them with Boolean algebra. So these searches could be really complex sometimes, depending on research questions. So here we see the filter that was developed by Cochrane that identifies randomized control trials in Medline data. So we see that researchers identified that we can either search abstracts for words randomized, placebo, randomly, or we can search specific fields, publication types, or we can use mesh terms, and we combine all of them. And this is the way that we identify a randomized controlled trial in PubMed data. Please do remember that when you do search, it is not expected that you will find everything you need in one search. Sometimes you need to do multiple searches. So it is something that my students are struggling with, they usually do one search and they either conclude there are no studies or there are too much studies. So we usually need to do multiple search. Also, while searching for studies, we need to make sure that we don't have publication bias. So now we know that depending on their results, studies have different probability of being published. So positive studies with large effects are most probably published. So in order to reduce the probability of this risk, we need to search also brain literature. This includes posters, and this includes going through registered trials to see whether something was published from these files. Hand searching, citation tracking, and so on and so forth, to see whether negative studies were missing in action. So this is an example of why publication bias can be really can really affect a lot of results. This is a study on 74 antidepressant studies that were registered with the FDA, and researchers went through their documentation, so results of all the clinical trials that were submitted to FDA. So they found that 97% of positive studies were published, but only 39% of neutral or negative studies, of which majority were published in a way that conveyed the positive results but emphasized the negative. And when they compared results of meta-analysis with just positive studies and all studies together, they identified 32% increase in relative effect size with only positive studies. So we are inflating effect by looking just at positive studies. And we need the systematic reviews. We need to identify whether we have publication bias or not. So at the phase of data extraction, we need to collect data from the study. Usually we have citation data, details, characteristics of population or intervention, including number of participants or timing of intervention or something like that, outcomes at baseline and follow-up, and methodological details. After data extraction, we need to do critical appraisal. Why? We already know not all studies are done with the same standard. Some studies are methodologically really poor. We need to identify those studies and see whether the fact that they were conducted poorly affects our overall results. So with quantitative studies, we assess internal validity of the study, bias, and external validity. Internal validity would be a situation where you perform randomized control trial, but at the beginning you had huge difference between the groups. So once you have the results, you don't know anymore whether it is due to your intervention or due to initial differences. We already said something about bias, and external validity is actually generalizability of studies. Many times we have situations where we cannot generalize our results, and you saw this study at the beginning on a red card, which obviously cannot be generalized on humans. So we need different tools for assessment. Cochrane risk of bias is usual for randomized control trials, but we also have different tools to assess risk of bias for other questions. So regarding data synthesis as the last part of systematic review and analysis, it has to do with building up all the studies together and giving one conclusion, one assessment of body of evidence. So, as I said, for quantitative data, we do meta-analysis. However, we really need to make sure that studies that we are going to meta-analyze are similar in a way that they are investigating the same phenomena, because often people want to do meta-analysis no matter what the cost is, and we have a lot of meta-analysis which are meaningless because they are summarizing quite different phenomena by different studies. We also can have narrative studies if meta-analysis is not possible, or we can complement meta-analysis narrative studies. So here is one example of meta-analysis with studies comparing thrombectomy to control in patients with acute ischemic stroke. So we have different studies. We have a point estimate of the effect. In this example, it's odds ratio, and we have 95% confidence interval around that effect. So we see that majority of studies are showing non-significant results. Just one study is showing significant results. Once we pulled all these studies together, we see that summary effect shows that there could be 0.16 reduction in odds ratio, where confidence interval includes moderate reduction of 0.33 to no effect at all. So although we improved precision of these studies with summary effect, we are still not certain what the effect is, because confidence intervals show that we could have a moderate effect, we could have small effect, and we could have no effect at all. In addition to meta-analysis and forest plots, this is actually forest plot representation. We can have narrative synthesis, which actually describe different studies. But the problem with narrative synthesis is that there is potential bias in presentation. You can present things differently. Like in the slide with mortality, we can say we cannot exclude there is no effect, or we can say, okay, this confidence interval is wide, it allows from moderate to no effect, and we need to increase number of studies. So we can present things differently, and it can be more difficult to provide a take-home message. However, what I skipped and now I went back, what is the most important in terms of evidence synthesis and meta-analysis is heterogeneity, or differences in studies. So differences between studies can be introduced because methodological heterogeneity or clinical heterogeneity. So we have different populations that behave differently, pediatric population with adult population, and so on. Or we can have statistical heterogeneity, where we know that we have heterogeneity, which is larger than expected chance, but we cannot identify what the source of heterogeneity is. So once we have our meta-analysis, we need to explore our heterogeneity well. If we identify the source of heterogeneity, if we use the source of heterogeneity in an analysis, we'll be able to reduce heterogeneity in the results. Otherwise, if we have high unexplained heterogeneity, that is always matter of concern, whether we actually pull apples and origins together and end up with meaningless. So at the end, we need also to think about quality of systematic review that we produce. Because not only the primary studies have many methodological problems, but also systematic reviews has huge problems. So we need to think about reporting quality of systematic reviews, whether we showed all aspects of systematic reviews, and whether our colleagues can judge the quality of our systematic review based on this. So one aspect of transparent reporting in this in Prisma guidelines is this, that we need to have Prisma flowchart, how we identified studies, what was the screening process, eligibility, and how many studies we included. So Prisma statement will tell us and will guide us while we are writing reporting system. We also have another tool called Amsterd tool that will assess methodological quality of systematic reviews. And this is something that also is good for you to check not only your own systematic review, but also systematic reviews from other groups, as fortunately, because people are very much interested in producing systematic reviews, we have many really poorly done systematic reviews. And that is the problem, because the scientific paper that we looked at as the top of hierarchy of evidence could be actually having a lot of problems. And okay, so at the end, I would just like to show you what the systematic review can do for science. So this is a case study of passive smoking. And the first epidemiological studies trying to solve this question appeared in 1980. From that time, tobacco industry attacked lots of studies on the same topic, claiming that the association between passive smoking different diseases is too weak. There are many potential biases, as is normal in observational studies. There are the results could be potential effects of co-founding factors, and there is no biological evidence. However, after evidence accumulated for several decades, 20 years ago, several official bodies came to conclusion about harmfulness of smoking. So, in this study, they collected studies in which women who do not smoke were compared based on the fact whether their husbands smoke or not. And meta-analysis found that risk of lung cancer in women who do not smoke but are exposed to passive smoking is 24% higher than in women whose husbands do not smoke, and 95% confidence shows that this risk is from 13 to 36%. So here we see how in time, by accumulating number of studies, the summary result of meta-analysis is more and more precise, and it's giving us definite answers. And the final slide, we also see how those effects was proven for these studies. We see here summary results for different groups based on number of cigarettes smoked daily by those and number of years living with those who smoke. So at the end, we really have solid evidence that passive smoking is really increased with different cardiovascular events. So thank you for your attention.
Thank you very much, Anna, for this excellent and also comprehensive webinar and lecture. And from my perspective, you clearly showed that undertaking of a systematic review and meta-analysis is something to really think about before you embark on such a major undertaking. It's time now for everyone to ask questions, and already I received three very interesting questions with which I would like to start. If the discussion is lively, I would propose that we could continue until 5 minutes after 12. But of course, everyone is free to leave earlier, but I would be prepared to stay a little bit longer. So moving over to the questions. The first question that we received in the chat is, Anna, what about preprints? Should or could they be included in the literature review if they meet the inclusion criteria? And those preparing the systematic review have the capacity to judge their validity.
So I will start with the second question. Those preparing systematic review should have capacity to judge their validity. And this is one of the problems with systematic review, where a lot of unexperienced people are actually doing critical appraisal. From my own experience, it's not easy to do unless you understand epidemiology, kind of. So, of course, this is something that could be learned, but you should learn with experience. And in time, you will learn how to do it. About the preprint, because of publication bias, it is proven all the gray literature, including posters, but also preprint, could be of lower quality because no one assessed it. This should be included. Operatively, because there are many different repositories and it's not easy to search for preprints, that could be an obstacle, but we would like to include them and also to assess their quality.
Okay, thank you very much. Yes. I think for sake of time, let's move to the next question, if that's okay, because there are quite many questions and I would like to cover most of them.
Yeah.
The second question was how to manage multiple publications, including the same or subsets of the same cohort, such as preliminary, final results, or extensions of a study over a longer follow-up in a larger cohort using different inclusion criteria to meet all the review inclusion criteria. So it's like a question on double counting or stuff like that.
Yes. So basically, we shouldn't double count. We shouldn't present same participants in two different studies in meta-analysis. So we need to decide what we will include in the analysis. So usually we identify all the multiple publications, we show them in preview, but we will analyze only the final data or something like that. So again, the final decision depends on what you want to investigate. If you want to investigate subgroups or population that are only shown in the first study of several, you will use the first study. But as a rule, we usually use the final.
Yes. So I could imagine that if you specify you're interested in the 12-month effect and you have effects after 3 years, you could still use the 12 months, right? But it would be pre-specified and in the public domain that's your goal. Yes. I received a message. Could you ask Anna to stop sharing screen? Oh yeah, could you stop Anna sharing screen? Then we would
okay.
have a better view.
Yeah.
Yeah. Thank you. Yes. So that was a question about double counting and being very precise in what you want to know. I think it's still probably a tricky issue, and maybe a connected tricky issue that I encountered is that you have like 5 publications on the same long-term trial or cohort, and then between the publications, the specifications about the exact details of the methodology also changes between the papers. Would you then, let's say, believe the collection of all the nice features on methodology, or would you say, well, yeah, what should we believe?
So I would be conservative. So if I'm concerned that the researchers changed the description of methodology, I would think, why is that so? And if they're trying to improve their results. So I would be conservative and maybe use the first study or explaining in the systematic review why I decided to use that.
Yes. And
Because
Mhm.
many times you make a decision because what you read between the lines. So in one example, I have one study that was outlier, for which I identified that they copy-pasted methods from another study.
Whoa.
So although in Cochrane, people are not very, they're not leaning toward excluding study. In this particular case, where I have the effect that was 4 times bigger than all the other studies, and I have copy-pasted results, I decided, okay, I will exclude the study.
Yeah,
But it
because,
is case-to-case based.
yeah, so that's an indicator of fraud. And if you think people will copy paste things that from another team, then they might also copy paste results or invent the results.
Yeah, you cannot say whether it's fraud. It could be that they miscalculated or something like that.
Yeah.
But you can be suspicious about it.
Yes. So that also brings us a little bit on the issue of sensitivity analysis, that you try out different things. You see that something is an outlier and you recalculate without the outlier and to try to comment on the issues involved.
Yes. So people are not very, they don't like to do much of systematic of sensitivity analysis, particularly because in many meta-analyses, you end up with 3 to 4 studies. So you can easily overanalyze your results. But it is always good to have some sort of sensitivity analysis, either based on quality of studies or timelines or whatever.
Yes, yes. I know that the Cochrane collaboration also has a policy on how to deal with papers that appear to have been retracted.
So luckily, I didn't use that policy because I didn't need it. I didn't have retracted papers in my meta-analysis.
Okay, so let's move on then to the third question from the chat. What is the best policy in the meta-analysis? To be really specific with the search criteria, at the risk of missing some studies that should be included, or have less studies to review, and have fewer studies to review, or alternatively be more broad in the inclusion criteria and then personally review all the studies that the search provides. So it's a little bit about the specificity of the search. Do you have like a wide gate, let everybody in, or you be very strict from the beginning and have a smaller sample to start?
Again, there is no one rule. Depends what you want. So obviously, if you have narrow filter, you will get homogeneous studies. But it could be that you will just identify few studies. So you can have a problem with that. With broad filter, you will identify many different studies, which are quite heterogeneous. You can end up with the problem that you're actually summarizing apples and oranges, and you can end up with the problem of having so many studies in your review. So you need to decide what it is that you want, what are your priorities, and something like that. So just remember, although we have so much guidance, the definite decision, operative decision, should be made on case by case, by case.
Yeah, yeah. I spent a year at Center of Reviews and Dissemination at York University. That's a long time ago, but we received many questions from the government to do systematic reviews, because the whole institute CRD is involved with producing systematic reviews, and of course there were industry partners involved with large interests at stake. There was always this discussion: should we focus on randomized trials only? What about well-analyzed cohort studies? What about evidence from animal research, or even prior to that lab research? It's all, I mean, if you're a Bayesian statistician, you would think, okay, I have some prior ideas from very fundamental research, animal research, observational studies in humans, and then there's this big divide, and then come the randomized trials. But there were discussions with people from industry say, why do you exclude all the prior evidence and only restrict yourself to randomized trials? And of course, this is a topic that relates to what we to the previous question. I really struggled with it, and as you said, it's difficult, but it's maybe to say you should decide on a case-by-case basis is not a true solution, and maybe there is no true solution.
So if we have a lot of randomized controlled trials, why would I think about animal studies? I have enough evidence on people, so with the highest level of evidence. So I would go with randomized control. Mm-hmm. If I have a problem with not many studies being published, I would be very careful, but I would gladly go and analyze observational studies too. However, I have to say that it should be experienced person who is introducing non-randomized studies into meta-analysis.
Yeah, so you would need additional expertise, so to say, in your team to make sure that different kind of evidence can be
because
assessed.
If the observational study is showing such a large effect that you cannot attribute to any bias that is larger than you expect biases to be, then there is something there. So we shouldn't disregard it.
Yes, we are lucky to have in the Camarades collaboration, which is like a Cochrane collaboration type of organization for animal studies, and they have a lot of expertise how to deal with more fundamental, more lab animal experiments. Mm-hmm. Yes, Camarades in Scotland. The final question from the chat was, can you use really specific inclusion criteria? That is, studies, for example, in individuals aged over 40 years? And if so, do you look at the mean values of the age of the participants in the studies? Or do you look at the inclusion criteria of each study in order to decide if it's eligible for meta-analysis?
So if it makes sense, yes. So if you have a disease which behaves differently in those older than 40, then yes. And for inclusion criteria, I will look at distribution, so not only mean and standard deviation. I would say I would include patients, studies where 80% of patients are older than 40. So you need to clearly state the threshold of inclusion. You look at distribution of age in each study, and then you make your decision.
Okay. We have 3 minutes left before it's 12:05. So the chat is still open for questions. I had noted down a few questions that arose in my mind while while I was listening to your talk, Anna. I've always been a little bit puzzled by the formal relationship between the results from the critical appraisal and their inclusion in a formal way in the statistical analysis. I've always felt that you do this critical appraisal and then there's no reflection at all in the final graph that you make. Of course, there have been these experiments by ranking them with a quality score, but that has become very the object of criticism. So nobody, hardly anyone ever tries to do that anymore because they will be shot down. But there remains this issue of critical appraisal results, and then you have the forest plot, and what is the relation?
So we usually use information from critical appraisal to do sensitivity. To answer the question, if we use only studies with low risk of bias, so the studies with high quality, do we have different results? So do we have effect of different studies of lower quality studies on our results? And this is actually the only way we use quality appraisal. There is one model, analytical model, which was introduced recently, which also used critical appraisal as a variable in synthesizing the evidence.
Okay.
However, it's not frequently used. So mainly we use fixed and random effects, and in that context we use the information from quality assessment for sensitivity analysis. However, for quality assessment, I also need to say that this is actually qualitative assessment, and people can have quite different results because several experts reading the same text could reach out, could end up with different conclusions. So we need to bear in mind that risk assessment is not perfect. We need to improve it. Whether we can automate it, I'm not sure at this level, but maybe in the future.
Okay, thanks, Anna. I want to draw this meeting to a close. So thank you again, Anna Jeroncic. In the interest of time, we'll bring this webinar to a close. Thanks for investing your time, Anna, and present this to us. And thank you all people who have attended, asking questions and taking part in the discussions. VascAgeNet will be hosting future webinars every month until the end of the year, and we look forward to welcoming you then. So from Professor Anna Jeroncic and myself, goodbye and see you next month. Bye-bye.
Thank you. Bye.